Hello, everyone, and welcome to another episode of Solving the Advent of Code in Rust and trying to learn Rust in between. I'm Eugene. We have Roberto and Luciano.
Hello.
Thanks, everyone, for following along. If you never did Advent of Code, this is a coding challenge that's published every year in December, in the days leading up to Christmas. We're working towards last year's one. There are 24 challenges that you can find on adventofcode.com, and we should have a banner for this, hopefully. We publish all of our code on GitHub. We have a repository there, and we should hopefully also get a banner for that, for the GitHub repo. Eventually, give it a second. The internet is slow today, you know.
It's the eventually day.
Exactly. Right, so we publish all of our code on GitHub, and we have a YouTube channel where we publish all of the recordings. You can find the link to that in the description of the Twitch channel. And if you're watching this on YouTube, we stream every Monday, 6 p.m. Ireland time. You can find the link to that in the description of the YouTube channel. So last time we solved episode 16, exercise 16. Today we're going to be looking at exercise 17, which is called Trick Shot. I'm going to quickly walk through the README to kind of explain what the requirements are, and then I'm going to get Roberto to show you a solution in Python, and Luciano to show you one in Rust. We'll step through how we did it, how we solved it, and all that. So if you could switch to my screen, please.
I think I can. Okay, this is Roberto's one, so give me a second.
Yeah, as you can tell, because we had a little break, our Twitch streaming skills have gone a bit rusty. But not in a good way.
In a rusty way.
In a rusty way.
Are you sharing the right screen, Eugen?
I hope I am.
I see a Google Drive.
A drive? Serious? Wonderful. Yeah. Let me share again. Hello, everyone, and welcome to Adventures
of Screen Sharing. Yeah, as you can tell, we are back from holidays, so our mindset is not the usual.
Yep. So let's try this again and see what happens.
Have you tried to turn it off and on again?
I have, but to no avail. Right.
Now.
Can you now see the GitHub?
We should see the GitHub tab. Eugen screen. Yeah.
Cool. Thanks, everyone, for bearing through that with us, and apologies. It's usually a lot smoother, but yeah, today is Monday, a different Monday. So this is day 17, Trick Shots. Essentially, there's a big, long story about Santa's sleigh and some keys which have fallen into the water, and we're on a submarine. Anyway, the point is our submarine can shoot probes. We need to reach a specific place in a two-dimensional plane, and our probes have an X velocity and a Y velocity, basically. There's a little drawing here that kind of draws the projectile's path as it will take it. They're all meant to land within the space described by the T's. That's where we're going to have to find the keys. So starting from 0, 0, which are the submarine's current coordinates, we have this two-dimensional plane. We will shoot probes either in a positive X direction or negative X direction, or positive or negative Y's as well, with a given velocity at the start. From that point on, we're meant to find out in part 1, which is the highest, the biggest height that our projectiles will reach and still land within the target area. And part 2 we'll discuss when we actually get to it. But you can see in these drawings, there's one starting point, and then the projectile goes up 2 things, and then it starts descending due to gravity. It's also slowing down due to drag. They're defined a bit here. There we go. So due to drag, the probe's X velocity changes by 1 towards the value of 0, and it decreases by 1 if it's greater than 0. Sorry, it decreases by 1 if it's greater than 0, meaning if it goes left to right, or it increases by 1 if it is less than 0, meaning it goes right to left. And if it's already at 0, it stays the same. So drag only applies until you have no more velocity. And due to gravity, the probe's velocity decreases by 1, which means whatever vertical velocity we have, it'll just keep decreasing by 1 at every frame of the simulation. So with this in mind, the first goal, the first question that they ask us, is to find the initial velocity that causes the probe to reach its highest Y position and still eventually be within the target area after any step. So we have 2 solutions for this. We have a Python one and a Rust one, and I'll let Roberto explain the Python one since he wrote it.
Let me switch to screen.
Thank you.
There you go.
Okay.
You are on.
My Python solution is the stupidest one, so the most stupid you can think of. Why? Because I'm simulating the shot of the probe for real. Obviously, getting what is the maximum height, landing inside, velocity, and stuff like that. You could have used math to figure it out, like Luciano did. I went for the simplest, fastest, dirtier way, like always, and I simulated everything. What is the output of this simulation? Is those are trajectories. For example, starting from 0, 0, landing within the example rectangle that is, I don't remember. Let me scroll up to see. Okay, the readme input are 20, 30, minus 10, minus 5. Let's go down.
Oh yeah, we never went through the inputs. Apologies.
Yeah, those are the inputs for the readme. Mine were different, obviously. But as you can see, there is this trajectory with starting y of 0 and x of 6, I think. Then there is another trajectory that is landing within, another one that is landing within, and so on. And going on and on and on. Those are all the trajectories that land within the square that is defined by the input. At one point, here, out of this scale, there will be the highest one somewhere here. So for my input, that was this one, target area, x equal 25 to 67, and y minus 260 to minus 200. This was my area. What I did was taking input all the possible coordinates. This n is the number of simulation, the square root of the number of simulation I will do. My retard value, that is the max y, is 0 because it's the minimum height I can have. Then I start to have my n by n simulations. I have my vx and my vy. My vx is my number modulo the number of simulations. Then there is the division to have the y velocity. This is my initial velocity in x and my initial velocity in y. I keep a copy of them that then I'm not using anymore. But why am I keeping a copy of that? Probably I was retarding them just for curiosity. But I don't need that anymore. My initial position is 0. While I'm on the left of the rightest point and above the lowest point, I do my simulation. So I change my x and y by the velocity. Then I change, if the new y I reach is greater than my local maximum, I update it. Then if I'm inside the rectangle defined by the input, I will yield the maximum value of y. This is made with a generator, because then after this I will take the max of the value generated to get the maximum 8 I can reach. This is the maximum 8 of each simulation that is yielded. If the velocity of x is greater than 0, I decrement it. In this simulation, I'm not only shooting to positive x's, because is the only direction I can land within the rectangle area that is defined in the input, even the readme and even my input, so no negative x in account. And the y velocity is decremented by 1, like the readme is saying. Doing all of these simulations, I get my output. Here I'm parsing the numbers with regular expressions. The input is this one, is a target area, x between this and that, and y between this and that. What I'm doing a regex that say, take a sequence of numbers and a minus sign, if you find it. And this is matched 4 times in that string. So my numbers will be a list of 4 elements, 1 for each number. I map them to an int, because the regex is giving you back a string. It's not giving you back an integer. I map that as an integer. Here, I'm passing those 4 integers, decomposing the list in parameters to part 1. So part 1 is getting the 4 numbers here as a single parameter starting from a list. Obviously, here I'm not checking the number of parameters. If the input is malformed, this will just trigger an exception. And then I'm taking the max value of the generated of the generator. The generator is shooting me out top y coordinate of all the possible parabolas that are true here, and I'm taking the max of that. Is running in a reasonable amount of time, less than a second. That is not measurable, so it's fine, even if it's a simulation of a lot of trajectories, but because those are just simple math. Luciano approach is way smarter.
Should I show mine?
Yeah, because
okay, so I'm gonna caveat that I don't remember what I did.
I think
why I did it in a certain way, but I found a nice explanation on Reddit that I think is similar to my reasoning at the time. So I'm going to show you the solution first, and then we'll try
I
to
think I
explain
understood
it.
what you did. I will try to explain it before reading the Reddit one. Then we read the Reddit one, and we see if I guessed it right or wrongly.
Sounds
And
good.
we can have a poll about it.
Yeah, we're taking bets on was Roberto right.
Yeah, we are not paying bets, but we are just taking them.
Yeah, bet with yourselves.
Okay, so now you should see my screen. So let's
I can
start with.
see what? Okay, now I can see yours.
Let's start with part 1 first. Let's ignore this one for a second. The first thing that we do is we parse the input. So we have a struct called target area, and that struct can be created by parsing the input. Very quickly, let's see how that's implemented. So target area as essentially is a rectangle. So you have minimum x, minimum y, and maximum y. And then you have only one method that is literally telling you, if I give you coordinates x and y, is that contained in the rectangle? And there is a parsing functionality, so this is not different from what we had done in the past. So there is a lot of split ones and trying to make sure that we can extrapolate the input from this particular syntax. So we split here first, then we split by the comma, then we take x and we split by the 2 dots, and we have minimum x and maximum x. And similarly here we split by the dots, and we have minimum y and maximum y.
Curiosity, would regex not have worked?
Yeah,
I don't think we've ever used it in Rust yet, no?
We did, and I think at the very beginning, at the very, very first episodes, so this was like more than 1 year ago at this point. And I think the issue is that you need to install a specific crate because regex are not part of the standard library.
Oh yeah,
and then it's a little bit quirky and slow to use regex. So, but I mean, we could try to redo this with regexes and see how it looks like if you're curious.
Yeah, fair enough.
Why not use a question mark? Tommaso is asking, and it's a good question. Let me see if I can show it.
You're right. We have a chat.
Yep, I was neglecting the chat. So actually, this is a good question because here we are using a lot of unwrap. And if you know anything about Rust, unwrap is a little bit of a bad practice because you're basically saying, if this is actually an issue, meaning in this case, if you cannot split, right? When you unwrap, you actually are creating panic because you are literally saying, I'm sure that this is correct, so just unwrap it. But if it's not correct, the program doesn't know what to do, so it's just going to panic. But the trait that we are implementing, which is a from string, actually supports errors. So in theory, we could write this one a little bit better by actually propagating the errors. So yeah, I suppose Tommaso is telling us to be a little bit more responsible and do the right thing. So we could at least use expect, and expect is still going to panic, but at least you can specify a custom message saying, okay, this thing did panic because we were expecting a certain thing and that certain thing didn't happen. So maybe let's keep it as a to-do element to refactor this function and make it a little bit better in terms of error management. But anyway, at the end of this function, we end up with a target area object with all the properties. So we effectively parsed a rectangle out of this type of string.
Mm-hmm.
Does that make sense?
Yeah.
Then the other thing that I'm doing is where the cleverness starts, because basically I'm saying that minimum y is basically the minimum y of the target rectangle. Then what I'm doing, and this is actually the trick, I am assigning the velocity of y to this particular formula, so to minus minimum y, minus 1. And then I'm starting with y equals 0, and then I'm doing this simulation. So I'm saying vy, as long as it's bigger than 0, keep increasing it. And so keep increasing the height, basically. And vy minus equal 1 is basically decreasing the velocity at every step. And then at the end of the day, we return y. So the idea is that when we reach velocity 0, this is basically the highest point, and we return that highest point. Now, this is the interesting part. Why I'm doing this. First of all, I'm not even focusing on x because I am kind of decoupling the movement of the projectile. I'm decoupling the x-axis from the y-axis. So I am assuming that for whatever trajectory on the y-axis, there is going to be a trajectory on the x-axis that is going to hit the target. So for whatever maximum curve, I can find something on the x side that will fit the rectangle. But that doesn't really matter because the problem is only asking you for the maximum height. So I only need to be careful at hitting the rectangle on the y range. And I remember, I'm not really sure if I remember the formula, but basically this thing was a way to say, try to hit the rectangle at the minimum height. So the last step is going to hit the rectangular leader at the bottom border. So if we take the README and we take an example, that basically means I'm going to try to hit the rectangle somewhere here. And that basically resulted in this formula. Now, I don't really remember how I came up with this formula, but that was the...
Yeah, I think I figured it out. When you do this kind of simulation, you start from 0, 0. Then you start with a velocity. In your case, you start, I don't remember what is your input.
My input is...
you are targeting minus 150. So
exactly.
you start with 149.
149, yes.
49. Then you sum 149. Then you sum 148. Then you sum 147. This is Gauss. And then you go up to 0. When you reach 0, you start to fall. And you fall with the exact same sequence of numbers, just from 1, 2, 3, 4, instead of counting down.
Exactly.
When you reach again 0, with a velocity, negative velocity, of minus 150. At that point, from 0, you go minus 150, you reach the bottom of your target area in one step, and that is the fastest velocity you can reach without skipping the area, because you start from 0, you go up and you go down, you will always be on 0 with a step. And then what is the maximum velocity at 0 that you can have to still land inside your rectangle? It is minus 150, because if it is minus 159, you will jump over the area, and that will not count as landing within.
Yeah.
You can even make this faster, removing the loop.
Because, I suppose, we can just use the Gauss formula, right?
You can use Gauss. So now, run the test so we show that this is working.
And we actually have 2 tests, because we also tried Roberto's input. So this one is working, and this one is working.
Yeah.
Now, if we do Gauss, basically what we want to do is say, actually here, we can say y is equal to...
is equal to Vy multiplied Vy plus 1, between brackets, Vy plus 1, everything divided by 2. Now, I don't know if the types here are complaining because there is a division.
They're integers.
Let's see. Should be able to do an integer division.
Yeah, it's not needed to be mutable. You can even return it directly without assigning to a variable.
This one we are not even using it.
No,
right?
you need it, but not
it doesn't need to be mutable. Yeah, you're right. Okay, let's see what is it complaining about. Unnecessary let.
Yeah, because you can just return the...
Yeah, you can return it directly, yeah.
Be happy.
He's happy with the type. I removed the semicolon because... okay.
I did. Yeah, let's try.
Give it a shot, yeah.
Works.
Beautiful.
And it works.
And obviously, any kind of math is faster than a loop.
Yeah, we'll need to re-explain this one a little bit better, I think.
Yeah.
Okay, so...
hopefully this made sense to people in the chat as well.
Yeah, feel free to ask questions and we'll try to answer them. Or if you have other suggestions on how we could do this differently, that's also accepted.
Yeah, GitHub pull request, you know how to do it.
But basically, if we want to explain this a little bit better, is we don't care about x because we can decouple the 2 axes, and we focus only on finding x. Right? Right?
Yeah. We can say that starting from 0, we reach a top, and then we have to, and we will for sure pass by 0 again, coming down.
We will eventually...
because the progression going up is the same progression coming down. So we will be for sure at one point in 0 going down. The maximum velocity that we can have at that point is minus, in your case, 150. That is your minus... it is your mean y. You have called it mean y in your.
Okay, so this is the maximum velocity at the beginning, at step 0.
Think of you go up from 0 with a velocity that we don't know. You reach a point, then you start going down. At one point, you will be already again in 0 because you started in 0 with a progression, and you go to 0 with the same progression, just flipped. At that point, you need to have the highest possible velocity, because it means that you were the higher as possible, but that velocity must be less than mean y, minus mean y, because if it is more than that, you will skip the area. So you know that
that's why we do the -1.
Yeah. So you have to be at least inside that from there.
Okay,
Then you know the velocity that you must have in 0 going down.
Mm-hmm.
Once you know the velocity that you must have in y0 going down, at that point you can tell, okay, if here I must have velocity of n, it means that I started from a velocity, an 8 of n by n plus 1/2. That is the Gauss formula. And that is the height that you started from.
Let's show this example. So if we start with a velocity of, let's say 5, right? Yeah. We are initially at 0.
Yeah.
Then we are at
then
5.
Then 9.
Then 9.
Then 12.
12.
14.
Then 14. Then 15.
15. Then you start going down.
Then this is where, yeah, let's...
It is 14, 12, 9, 5, 0.
Which is basically the reverse, yeah. 12.
Yeah.
Oh, look at Copilot.
Yeah. Thank you, Autopilot. I don't know why it's...
I don't know why there is at 0 at the end, but...
because it's going up and it is doing a sinusoid, probably.
Some of it is correct.
Yeah. If
and then
it was
minus 5, minus 9, whatever.
Yeah. If, for example, our velocity, our minus y was minus 9, we could have started with faster velocity.
Mm-hmm.
So what I want to show is that basically...
If our minus y was 5, this was the progression. So you have to start with a velocity of 5. If your minus y is 9, at that point you can start even faster, so you can get higher.
Is 0, it's not negative. Okay, so what we want to say is that if we take initial y as minus in
initial velocity in y, not y.
We basically end up with a Gauss series because it starts from 0.
It's the same Gauss series, just inverted.
Mm.
And the velocity in y, this is the quote. The velocity is going in the other way. Is incrementing instead of decrementing.
Yeah, I suppose the reason why is the sum of the first n numbers.
Sorry, repeat.
Why are we using the Gauss formula? I think there is some step missing here.
Because the velocity is decreasing by 1 at each step. If it is positive, it's doing a Gauss going from 5, 4, 3 to 1, 0.
Mm-hmm.
If it is starting from 0 and going down, the velocity is minus 1, minus 2, minus 3, minus 4. That is again a Gauss, just a negative Gauss. And it's for this reason that we do minus min y, because our velocity is a negative velocity.
But min y initially is negative as well. So this would be...
Yeah, in our case, yes. But
so in our case, this will be minus 150 will be 149, right?
Multiplied by 150, sliced by 2, divided by 2. That is.
So this would be 149. Then we add 148. Then, it's magic.
No, it is 149 plus 148, the 8. That is the speed.
Yeah, so will be almost 300, 298, I think.
You don't want to do the math by memory with those numbers.
Okay. So how do we explain this?
I think it's explained well enough.
You have to reach again 0 with the highest velocity possible. The highest velocity as possible is minus min y. When you are in the descending parabola, you have to reach again 0, and you will reach again 0 because the progression going up is the same progression going down with the highest velocity that let you still be inside the square, the rectangle, not the square. It's not a square. Why you want the highest velocity? Because it means the highest velocity is the highest height.
Mm-hmm. And this will be in one final step. From 0 to the rectangle.
0 it will jump exactly at the bottom of your rectangle.
Okay. Is it clear enough? I hope so.
I think so.
Okay, let's go to part 2.
Without adding a simulation.
Twitch says somebody just left, so probably not clear enough. Or they've had enough Gauss for one evening.
Should I go part 2, or do you want to show again?
Do you want to read the readme for part 2?
Yeah. Who is going to do that? Should I do it?
I can do it if you share my screen again, if it's working this time.
Yeah, if you are not sharing your own banking or stuff like that.
I am.
Yeah,
Take
yeah.
the money and run.
That's it. So essentially, part two, well, as is tradition with Advent of Code, it's based on the setup from the first one. The only difference is that this time we need to calculate how many distinct initial velocities cause the probe to be within the target area after any step. So essentially, which combinations of x and y velocities will land us within the target area. It doesn't matter which is biggest or smallest, it's just which ones will take us there. How many are there? Again, with the same setup, you have the same submarine, the same plane, and the same input data. Would you like to go through Roberto's first, or would you like to go through yours first, Luciano?
Oh, we can do mine first, and then
Let's
we can see
go.
the rest.
Let's go with Python. Let's follow the tradition.
Okay.
We already have traditions. Cool.
Yeah.
You're on.
Okay, so going back to the graph from before, all the possible probes that are landing within the rectangle. In the case of this, of the README data, those are all the possible trajectories that go inside the rectangle. As we see, there are some of them with positive y's that go up here, and then they just the x is stopping here, and they just start to fall vertically until they land somewhere in the rectangle. Other probes are directly fired inside the rectangle. Think of the first step of a probe with minus something that is going here in y, and x something that lands within. So there will be a lot of them that just go through directly, and some of them that go there passing through other steps coordinates with a parabola. In the case of the README, I think there are 112 trajectories that starting velocities that goes inside the rectangle, 112. I hope it's the same number that is in the README.
Yeah,
It's the number that is here in the simulation.
Yeah, the
So
README also
going
had
to
112.
Code part 2 here. Okay, my input is slightly different from Luciano ones. I can put Luciano ones here, but this is fine. I created a part 2 function that creates a generator that is this generator is simulating all trajectories, given an initial v in x and v in y, and when a coordinate is inside the rectangle, it yield the velocity, this initial velocity that was used to reach this point. Again, it loops only until we are left or the rightmost position and above the lowest position, because it makes no sense to simulate after those points. Same rule as before, x decrements towards 0, vy is always decrementing by 1. I'm taking n by n simulation, so my speed is between 0 and 300, and my y speed is between 0 and 300. I yield from the generator for positive velocities. Then I handle the low balls that are the probes downside with negative velocity. So I'm taking the same positive number and I'm just putting a minus in front of it. Too complicated. I'm yielding from that is again this generator. So part 2 is a generator that yields from generators, and the other generator is this sub-generator. Again, I'm parsing all the input with regex. I'm passing the composed list to part 2. I'm making a set to remove duplicated velocities. I don't think it's needed. I did this, but who cares? It's creating a set to remove duplicated velocities.
We have a question from Tommaso. He's asking if yield from means yield all values returned by the generator.
Yeah, exactly. Doing yield from is exactly like doing for value in generator vx v. Wait, thank you. Y yield value. Yield from is the. Why is jumping around? Yield from is the same as doing this for loop.
Which is the same as yield star in JavaScript. It's like delegating yield or something like that, I think it's called.
Yeah.
In Python, basically, it was created because it was very common when you do combinator, permutation, combinations, those kind of stuff. You yield in a generator from a recursive call to itself. So you were doing a lot of this kind of stuff. So they said, okay, let's create a yield from. That means exactly do this loop for me on top of all the outputs and yield them like I was the one yielding them. So you are not yielding a list, you're yielding the single values of the other generator. So those two ways of writing are exactly the same, only that this one is more readable because it's one line.
Yeah.
Instead, here is a loop that yells. So yeah. In the end, it's exactly the same. I think even internally, the bytecode is the same. It's just a syntactic shoe.
Cool.
So again, taking the set that is the list of all the possible velocity and taking its length. In my case, it was 4903.
Yeah.
So here I'm doing all the simulations.
This makes sense. Let's see Luciano's, unless we have any questions about this.
Okay.
Only the yelled from that. I hope I explained it clearly enough.
It was clear,
So-
and Tommaso seems happy with it as well.
Okay, so part 2, we pass the input as well. Then we get the minimum y. We have a counter for it. And then what we do is we create here a range that goes from 0 to max x, and a range that goes from minimum y to minimum y minus 1. So at this point, we have all the combination of values between these two ranges on the x-axis and these two values on the y-axis. And we create a prob, which we're going to see what it is in a second, for vx and vy. And this prob has a method, its target, which contains all the business logic. And if it eats that particular target, then we count the hit, and we return at the end the number of hits. So now...
Okay, all of this, I think we already did all of this some times ago in one line with only one, because when you count something, there wasn't something in Rust to...
Oh, you could do probably...
If probe, you filter only the probe that hits the target, and then you do a count.
If we do all of this as a iterator, I guess, then you can just do dot count.
Yeah, okay. I was remembering that we did this before, but it's fine like this for now. I just wanted to...
We could try to have an iterator that give us like all these combinations of range, like, I don't know, rectangular range. We can do an iterator for that. And at that point, we can do a map.
To have a probe.
And then a filter.
Then a filter with the hit target function.
Yeah, and then count.
And then count, okay, yes.
So let's put a to-do. Make this use...
And this square iterator, I like...
A proper iterator, I like Copilot. Copilot knows...
Copilot is reading your code and
our minds.
It's reading your code, and because if you look, I think that comment is somewhere in the GitHub history, for sure. For sure.
Or Copilot is just being judgy.
Yeah. I point more money on this reading our GitHub history.
Copilot is a good Copilot.
Nice.
Okay, I think I'm ranking up as a developer, but just using Copilot. Don't tell my boss. Okay, so let's look at the prob. So prob, as we said, is a struct, and it contains a bunch of properties: velocity x, velocity y, position x, position y. So when you create it, you need to pass the current velocity x and y, but it's always going to start from x0 and y0 because this is a requirement in the README. Then this is the only function we are implementing, its target. So basically this function, what it's doing is starting from, we have a max y, max x and max y from the target. So we need to pass a target. So this is basically the limits, right? If we go, as Roberto said before, if we go over these limits, we overshoot. So basically what we do a loop. So this is like a while true. And then we say, if the target contains the current position, then it means that the current position is already in the target. If not, we simulate another step. And here we have iterators. So we'll see this in a second. And basically then we check if overshot, it is missed. So we need to break the loop and return false. So in the current step, if we are inside, we return true, and this breaks the loop. Otherwise, we keep simulating. But if we overshoot, we interrupt the loop and we go out and return false. Now, this self.next is because we implemented iterator in this probe. And basically next, what it's doing is effectively describing the rules of physics that we want to apply. So at every step, how are we changing x and y? How are we changing the velocity in x and y? And these are the rules. So new x is going to be the current x plus the current velocity x. New y is going to be the current y plus the velocity y. And then we need to apply the deceleration. So in the new velocity x is basically the current velocity x plus something that is defined by this match statement. And this match statement is saying if the current velocity is 0, then we need to apply 0. If it's greater than 0, we need to decrease by 1. If it's lower than 0, we need to increase by 1.
And question.
Yeah.
Is there a reason why you didn't use the plus equal and you created new variable, then you reassign it back to the self variable? Or could you have used the self x plus equal, self y plus equal, and so on?
I think I could have done that. I don't see any reason why not. I think it was just cleaner for me this way to do new x, new y, new vx, and new vy, which is just decreasing by 1 all the time because gravity.
Mm-hmm.
And then I just reassign all the values, the current values with the new values.
Yeah, but it's not a Rust limitation. This is just that you did like this.
I think so. I don't see any reason why. We can try, I guess. Like if we try to do self vx, for instance, just to try out.
We use vy. That is very simple.
I think, yeah, that should compile. Except here that doesn't know this new vx.
Instead of equal, can you use plus equal and remove the first self of vx in line 79?
I think so as well.
And also that plus that is now okay.
So
okay, you could have.
I would leave it as it was because I don't know. I personally find it more readable. So this is nothing special. It's just, this is pretty much all the code. Now, do we want to try to do that?
Try the test before this, just to...
Oh, yeah, you're right. Let's run all the tests. Yeah, all passed. So do we want to try to do this kind of rectangular range iterator?
Yeah, how can you do that in Rust, a rectangular range iterator?
That could be interesting. Let's try. So let's try to do
Is there something already in the core?
I don't think so. It's thinking that we want to do a point, by the way. Struct rectangular range.
Answer to Copilot, mind your own business.
Pretty much, yeah. So what are we gonna have? We're gonna have min x, and it's an i32. Min y, and it's an i32. Y is
Minx.
And then we're gonna have max x i32, and then max y i32. Do we need to also keep the current, I guess?
Quick thing, Tommaso was asking if the iterator is a correct usage here. The item is what looks like a tuple, but I'm not sure what this means.
Probably is talking about the fact that we return some.
Oh, probably the previous one. In the previous one. In
you are using an iterator to just evolve an internal state. Yeah. You're not returning anything from the iterator.
Right.
Yeah, this is a good point. I think I personally do that. I tend to abuse the iterator trait every time I can do like a simulation of steps.
Yeah.
But in reality, when you're not returning anything, doesn't really buy you anything, because you cannot really build combinators. You just need to call .next manually. Or I guess maybe if you just want to count how many times you iterate before something finish, could be useful, but again, it's a little bit of a stretch. I think Tommaso's point is correct in saying, maybe we didn't really have to use an iterator to do this.
It's working, but probably it's a stretch of the use of iterators.
Yeah, it could have been an internal method called
update.
I don't know. Yeah, next phase or simulate next frame, whatever we wanted to call it.
Yep. I'm sorry for taking so long to actually see the message in the chat.
Okay, so now what we want to do is implement iterator for rectangular range, and basically the iterator trait says,
just to suggest, instead of using min x and min y, you can just call them x and y, because we will start from them and we will just ramp up by 1 until max x. So
fair enough.
At every state, those are our values. No, but we have to go back when we reset. No, we need to keep them, and probably having also x and y.
I'm gonna do something just for clarity. So what we want to implement is literally this, something that yields tuples like this, right? So the logic that we want here is that at every step we need to implement one iteration of this.
Yeah, we have to increment the x, and if x is mass x, we must reset the x to min x and increment y. So Yeah, we can not keep the mean y. We can just have y, but we need an x for the current row, an additional field.
Yeah.
Okay.
And our type will be a tuple of 2 integers.
Our tuple of I32, which is the current x and y, right?
Yeah.
Mm-hmm.
Okay, so the state that we need is basically...
Add an x. You can add an x.
Can we say Vx, which initially is going to be 0 as well?
It will be mean x. That will be 0, yes, but it will be Vx. It will be mean x.
Which will be from 0 to max x.
It's always
Right.
0. If it's always 0, we don't need to keep a mean x.
We have a suggestion again, which says x and y can be I32s, dx and dy could be U32s. And max x will never be the minimum x.
I think dx and dy, you mean Vx and Vy? They can be negative.
Yeah, they can be negative.
Yeah, the range can be anywhere.
Delta.
The delta is always 1 because we are creating the iterator that is giving us the rectangular range. So the delta will always be incrementing by 1.
Yeah.
We don't need different steps.
Yeah, it's just max and min. So like the start and the end, basically. And the range can start at like -100 and go up to 0.
Do we have a constructor for this that is initializing the rectangular range?
Let's do that. Implement rectangular range, and we do fn new. What do we pass?
We can pass just... No, we don't need this. Going back to what we always start with an x of 0. So we have... Or do we want to do between min and max?
Right, it should be between min and max, right?
It depends on how much we want to make this generic. Or
let's make it generic. Let's go min max. Don't take Vx. Just 4 parameters. Keep the first 4 parameters.
And we remove this guy.
Yeah, remove that guy.
And this one
and
is 0.
Vx will be minus x at the beginning.
Minus min
no,
x?
No, min x. Without the minus. Min x. Okay. And min y, I suggest to rename it to Vy, min y. Or we can add a Vy and keep it separated, but we will never use min y at that point. You will see that min y will be never used, and Rust will tell
let's
us
do Vy I32.
Yeah. And Vy at the end of the constructor is min y.
Okay.
Now, in the next function, we have to...
We also need to keep track of current x and current y, right?
But the current x and y are Vx and Vy from what you created. This is not the velocity. This is just the rectangular range.
Yeah.
Mm-hmm.
We have everything that we need.
Okay, so basically what we want to do here...
Now here I want to ask you, now here we have to return Vx and Vy and then increment them. How do you do that? Because in Python with a generator is easy. You yield, then you do your logic.
Yeah, in Rust, generators are still experimental. You can use them under a flag, I think. Or there is a macro that you can install and it gives you something like yield !
No, but well...
So here now, we need to kind of build the state machine ourselves.
Our state machine is returning some Vx, Vy.
So basically we can say let to return.
Yeah.
Or item, I guess. And this is, I don't know, let's say 0, 0. We'll put the value later. Then we do item here.
It was suggesting self Vx and self Vy was correct.
Pilot knows everything. And then we return item at the end, but at this point we need to increment.
I think. Some item.
Mm-hmm.
Some item, you are correct.
Then we have also to, now we have to increment and check if we are at the end. At the point we have to return not some, but none.
Mm-hmm.
No, okay. So now, max x is included or excluded in this loop?
Good question. I think here we were including right?
Included, yeah. All the rest of the code.
This is what we do. Target max included.
Included. Okay. So
self Vx
plus equal 1 plus. There is plus in. No. Okay.
Self Vy.
No, just x.
The stack x.
Yeah.
And then
if Vx is greater than max x, so if we are outside of max x, greater, not equal, because we say that is inclusive.
Right.
If it's greater, self Vx is
equal
back
to 0.
Is back to min x,
minimum.
not 0, min x, because we are doing the
generic version.
The generic version.
And
And
instead
we have
increase.
to increment y, self Vy plus equal to 1.
Don't forget the semicolon.
That is already suggesting to you. Okay, here we have to do if, inside the days if, between line 38 and 39, if self Vy is greater than self max y, at this point it means that we are done, and we have to return known. Thank you, Copilot. You are smart.
And
Good.
then that's it.
That's it. And we are never using min y, as you see in this loop, because, like I said, we are never resetting back min y to the beginning.
Okay. So
we
there
just
is
use
another
min y.
comment.
Let's try if this works. If this works,
we
then
can write a quick test, I think, for this
that
one.
won't work correctly. Sorry, it will work correctly only if max x is greater than min x. Yeah, that is correct.
Yeah.
Should we write a quick
test? We are
test?
incrementing by 1 and always increasing.
Yeah, we're assuming coordinates in left to right.
The parameters.
Yeah, left to right, and then.
But it will work even in that case. I mean, it will just return nothing, return none immediately if you put the parameters in the other way around. Because Vx will be immediately greater than max x, Vy will be immediately greater than max x, and so it will return none at the first iteration. So you can create it with parameters in the wrong order. It will just do nothing. It will not crash. It will not loop.
Okay, so let's write a quick test for this guy.
Okay.
So let's do test fn test rectangular range, and we do let range equal rectangular range new. What do we pass? We pass from 1 to
5.
I don't know, another 1, and then 5 and 5. So it's a square.
Because there are min, max. Okay, sorry, because I thought it was. Okay, who cares?
Yeah, maybe it makes sense to do it in the other way around.
The parameters order are not important.
Actually, let's do 3, because otherwise it's going to be painful to write the expectation.
Keep them different so we are sure that it's iterating on the right values.
So let values
square to a rectangular.
Who has the dishes, by the way?
Maybe it's me.
Don't use 3 and 3. Use 3 and 5 or 3 and 4. 3
Good
and
point.
something else.
4. So what we expect to be the values? We want to do range dot collect
as a vector. As what?
I guess a vec
of U32. Yeah.
Tuples of U32. U32. Right?
I32.
Point.
We created I32, right?
Yes, we did. Okay. So now expected.
It was suggesting you something.
Jesus, is that correct?
Holy Jesus. It's probably correct, yeah.
I think it's just executing the code, and yeah, it is theoretically correct.
This is great.
Is it?
Maybe. It looks like it could be.
I'm not sure of the order. I mean, I think it will be 1, 2, 1, 3, 1, 4, 1.
Look at this.
Then I think Y and X are inverted here. But...
Okay, let's try. Now it failed. Okay, Copilot is not that smart. And Roberto is right. They are all inverted. Actually, this one, it's also skipping some.
No, it's going 1, 4, then going back to 2, 1, 2, 2, 2, 3, 2, 4,
yeah, but it did skip this
3,
one.
1, 3.
You see?
2?
No, it's there.
No, it's there. No, it's the Copilot order is not the right one.
But it is shorter, though.
By 1?
Okay,
Copilot can be wrong. Come on,
let me copy this one.
Let's read what it wrote.
Let's copy this one and let's read it and make sense of it. 1, 1, 1, 2, 1, 3, 1, 4. Then we go to the next line. 2, 1, 2, 2, 2, 3, 2, 4. We go to the next line. 3, 1, 3, 2, 3, 3, 3, 4.
But what makes sense?
Up there? Hang on.
No, it doesn't make sense to me.
Because the Y... So what's the max Y and what's the max X?
No, you copied the autopilot one again. You have to copy left, not right.
Oh, yeah.
Values.
Channel. You have to copy left.
Yeah, you're right. You are right.
No, there's also a chance our code isn't working correctly.
Yeah, but let's copy at least the right one. Okay. X must go between 1 and 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, scroll. And the last one is missing. The last one is missing.
So it's our code to be wrong.
Yeah, add a 3, 4 in the last line.
Yeah.
Cool. We are skipping the last element, and now we will explain.
So if we test this one, we should see that almost everything is correct, except we are missing the last one.
If we go back to the next, I explain why.
There you go.
Because we prepare what to return, that is the item. Then we have to return it. Then we have to check if the next one will be known. But we return known before returning the last item.
Yeah.
So how do we do that?
We can do the crappy thing of introducing a Boolean flag.
Basically, we have to do this check after we returned the value.
Or we can check the next value.
We can check it before. Okay, copy between 36 and 44.
36 and 44, okay.
That is the if, that is this one. Copy it before 32. Move it, not copy, sorry, move.
Move before line 32.
But then we're going to be skipping over the first one, though.
Let's try. I don't think so. We can try.
Well, we're modifying, so we're mutating Vx and Vy here.
We are mutating Vy only if Vx is... no, you have to remove the
Sorry, I'll shut up now.
Try to run it. Let's see.
Okay.
This self Vx...
leave it there. Leave it there. Right.
Okay.
I understand what you're doing now. Okay.
Correct. Because we are incrementing the variable for the next yield, for the next return, but before returning it, we check the item that we are going to return. And if it is outside of the boundaries, we just return known. Because we are outside of the Y boundaries, it means that we are done. Yeah, that's 0 in line 30. 30 is not a 0, but is a min x.
Yeah, this was the old code.
Yeah. So now let's try to use this guy.
Okay, so one thing that I would like to do though is like meanwhile, as you said, we never use it. So it's kind of useless that we keep it around. Right?
Yeah.
And remove it from the arguments.
No, the new is still needed because it's the starting value for Vy.
Ah, right.
Should we rename this one to
X and Y?
Current or just X and Y? Because V is like its velocity.
Rename them to X and Y only. I hope everything is fine and the editor is smart enough.
Perfect. So this is Y, this is Y, YX. Okay, cool. Now what we can do, and this is why we're doing all this stuff, is say let range.
Yeah, we can do everything chained, I think.
Oh yeah, we just create a rectangular range straight away.
Yeah, rectangular range this, then we do a map, then we filter, then we count.
Shut up, Copilot. I'm almost curious, is this what we want to do?
Possibly.
More or less.
Close enough.
Close enough. It's not a for each. We want a map and then a filter and then a count. No, Copilot. Mind your own business.
Calm down, yeah.
I think the parameters are correct. No, because we have min, max, max.
So let's... Oh, no, not all of that. Just that. So we have min y, and then max x, max y.
Because we made the parameters in a different order. Then on this...
But is that what we want to do? Because here we want to do minus y, minus 1.
Ah, yeah, you're right. Sorry. We want to do between 0 and max x. So the minus x is 0 and the max x is max x. Cool.
Minus y is minus y.
Yeah,
max
but on the
y
right,
is this.
Yeah, max y is minus y minus 1.
Okay. Then what we want to do is a map.
Yeah, sorry.
Where we take x and y.
And we return a probe of xy.
Second type. And we return probe new, this guy.
Yeah. Is there a shortcut to pass a map to the new of... No, but who cares?
There might be.
Oh, to just...
I think you can just... not sure you can...
But well, it's fine like this. It's working.
It's okay. Let's see if it works.
Okay, now what we want to do is filter. And we have probe. Ooh, look at that. Probe
this is, I think, correct.
And then count, which is also correct.
Nice.
Comment or... okay.
And we don't need all of this as well.
Cool. Oh.
Why is it complaining there? Expected function tuple stored found. Wait. Do we need
new?
to do...
You have to do a new in front of it?
Oh, yeah.
Makes sense.
Good point. Now, what is it complaining about? Expected items to do found U sides. Yeah.
Because count is giving a U sides.
Mm-hmm.
I mean, in fairness, we should have returned the U sides because this
Yeah,
is
because
just
it's a count of something, but
And what's
Wait
why
a
is it?
second. Is it gonna break the test? No, that's fine.
now
Now,
it's
why is it
complaining
complaining
about,
here? Cannot borrow prob as mutable, as it's behind a share reference
why do you need probe as a mutable?
because its target mutates the prob.
Mm.
Does it? I think so.
Yeah,
because
you're
it
saying
changes the self next.
how do you?
Can we not take it as a reference? Because like we don't mind.
Destroying them?
Yeah, we just need to get the true false
Oh,
values.
I think if we do filter map, that's the trick. We can get a mutable reference.
Okay.
So we have to do filter map altogether.
So basically, what we can do is, this is a little bit crap. Filter map, where the values are still these ones, Vx, and shut up, Copilot. Shut up for a second. These are the values, Vx and Vy. Then we do prob new, which is the prob. Let's say let prob, then we'll see if we can simplify it. And then what we want to do is...
Yeah, the one that is suggesting.
Pretty much this.
Yeah, but some probe, but we just have to
That
count.
doesn't matter, yeah, exactly.
We don't care.
Yeah, so
We just
return
want to count so we can return an empty tuple and count the empty tuple. But now...
And this one needs to be mute.
Cool.
And there is a way...
In fairness, we could have done even like this, I think.
Yep.
Yeah, the point is mutable.
I think so, that it's able to infer. I mean, it's not complaining anymore.
And is also giving the right result, or are we off by one?
It is.
Yeah, we made a rectangular range.
Now, this is probably going to be slower. We should have done benchmarks, but whatever.
Yeah, too late for that now. It looks prettier, so.
But if we do a commit, it should do the...
only if there is already something in main.
Of which
preparing the pull request against main automatically. Because it's for when somebody submit a pull request to check if the performance are improved or degenerated.
We just got a new follower. Thank you, Mr. Hooks.
Mr. Hooks, yeah.
And welcome. Hopefully you're going to find what we're doing somewhat interesting. Or if you know Rust better than we do, please teach us.
Here, can we write something cleaner, or do you think this is clean enough?
I'm thinking, do we really need that filter map?
Because we need to go from that range to a list of probes. Then take only the probes that hits the target, and then count them. The problem is that its target is changing the probe.
Yeah.
If its target was not modifying the probe, we didn't have any problem doing the map and then filter. And then
exactly, count. Yeah. And to be fair, I don't know if this is good design on its own, that you are doing a simulation that mutates the probe itself. And again, this is maybe because I wanted to really do that iterator thing, which
you like your iterators.
So probably we should refactor that as well.
Tommaso says we need the mute because there's an iterator under the hood. So yeah, I tend to agree as well.
We kind of reach out the same conclusion.
Yep.
Yeah. So what was the solution in Reddit that you found for part 1, by the way?
Let me see if I can find it again. I think it was this guy that was explaining very well. The same thing that we try to explain.
Are you sharing? Yeah, okay.
Yeah.
Sharing.
I think I can put this one in the chat.
Oh, yeah.
Oh, yeah, he's explaining what we did, basically. So I got it right. Cool.
Yay. Good job, Roberto. And whoever built
when you do the advent of code in real time, so this was the 18th of December, aside that I was eating a lot that day for sure. So my blood was elsewhere, not in my mind. You rush to do them because you want to be the first one in the leaderboard and so on. So it was faster to do a Gauss than all the simulation. But in the end, you needed the simulation for part 2, so why not implement it and run it?
Yeah, exactly. So here, I'm probably going to try to remove the iterator really quick.
You like iterators, eh?
So basically what we want to do is here simulate another step. We need to copy all this code inside there, right?
Yep.
Yeah, but without the self reference, you don't need to change self. You can have local
Exactly.
mutable
So
variables.
let me remove all this stuff. We can have local variables where
Outside of the loop, you declare integer mutable outside of before the loop.
what do we call it?
What X and Y are perfectly fine. What was your self X is your?
Yeah.
I don't remember exactly.
So
the
we
structure
have
of probe.
probe as Vx, Vy, X, and Y.
Okay, you also have to remember Vx and Vy in local variable because also those one are going to basically you copy your variables into local variables, all of them, and then you just play with them.
If I can type today.
So line 104 instead of self
So
X
this
is
is
just X. 104 also.
104.
Instead of self X is
You're
just
right.
X. So if we are inside the target, why true? I don't know. Because this is its target.
This
Okay.
Yeah,
So
exactly.
it's a boolean. Cool.
So
now, X is you want to keep the new X and new Y. Okay.
we could remove all of that and simplify, but for now, let me just make sure all of this works. And this is if X and
This
Y.
is overshooting.
Okay. This should be it, right?
Yes. At the point you want to change down there to map and then filter.
By the way, this doesn't need to be mute anymore.
No.
This should be a good proof that we are not mutating if it's not complaining.
Also, Tommaso suggesting that the best solution is to use a function, not a struct with a method, which is probably right because we don't actually need any of these references or anything.
Yeah, but we are changing less code in this way. Let's try if this works.
Yeah, let's do it incrementally.
Yeah.
So what we need to do at this
Guys,
point...
remember to do refactor a little bit at a time.
Yeah.
Not everything together.
Everything all at once. We wanted to crash and burn.
Yeah, then the pull request is like 600 files. I will look at that, 20 pages of code and saying, nah, I'm not code reviewing that today, but not even tomorrow.
So at this point, we can go again into map, and we have X and Y, and probe new, and then filter, probe,
It's target.
dot its target, and then count. And all of this stuff can be removed.
Is this still working?
Let's see. Yes, it is. So now if I can get into my suggestion, we can just do a function, probe it target, and replace all the stuff.
Yep.
Sorry, not all the stuff.
Not that one.
But where is it? This one.
Is it? Okay.
So let's say fn probe its target.
You have to pass a probe and the target. Return a boolean. Nice.
No, I think Tommaso suggested not to do a probe struct at all.
Yeah, that's my understanding as well.
So we just pass Vx, Vy, X, and Y, and a target.
But X and Y is always starting from 0. You don't have to pass X and Y.
Yeah, Vx, Vy, and target area. That's all you need.
Yeah, Vx, Vy, and target area.
Vx, Vy, which are I32.
Oh, come on, Rust, infer that. We are just doing
a reference to a target area. And what we return is a boolean. What are you suggesting there? No, I'm not going to...
Yeah, well, autopilot, go home, you're drunk. Well, the let mutable X and Y, it was fine, but we have code to copy and paste.
So we have
copy all the body of its target, and then we
cut it out.
And what we need to do is max.
That is fine. X starts
this is
from
0.
You never named the target area.
Oh yeah.
Sorry.
Target.
Good catch.
Column.
And now this is Vx and Vy.
Yeah, those are mutable copy of Vx and Vy. We have to make a mutable copy.
Do we? I think it's just gonna work.
Yeah, because they are changing during the loop.
But we are owning them. They're.
We are owning them, so we don't need to. Okay.
I think that should be fine.
It's complaining.
Is it?
Cannot assign to a mutable argument.
Okay, so we need to probably do. I didn't know that.
Call it the initial velocity or original velocity.
We can just shadow it, I think.
We can shadow it? Cool.
Yeah.
Oh.
Smart.
Tomas is suggesting something crazy. I don't know if it's crazy, but it's interesting suggestion. You can consider an order function that having a target area that never change inside the loop, return a closure that accepts a tuple and returns a boolean. I don't know if I want to
return a closure. No, thank you.
I am scared about the Rust FN, FN1s, FN mute, and all the rules around that.
That's a very JavaScripty thing. I like it though.
Okay, so is that it? I think that's it, right?
I think it's everything.
Should work.
So let's clean up all the probe that we don't need anymore.
And then we'll need to clean up this code as well because it's got some redundant stuff. And my internet's pretty poor today. Sorry.
And basically, the last thing we need to do here is going to complain that probe new doesn't exist anymore. But we have... Actually, we can just use filter.
Yeah, we can just filter.
Yeah.
And at this point, this is X and Y. And we have probe its target.
X, Y, and target. And reference to target. So.
That's good.
That is
complaints. The referencing, the borrow?
Because filter is borrowing. Hey, we can borrow. It's not a problem. We can accept the references to integers. We are copying them or not.
Yeah. But...
I don't think it makes any difference in reality because the size of a pointer and the size of a copy
the
is
size
the
of
same.
a pointer of an integer is the same. Cool. Still working?
Let's see.
Star makes a copy.
Still working.
Wonderful.
What is complaining about?
Probe has but is intentionally ignored during that code analysis. Okay, we can clean up here something.
Yeah, but it's not anymore at this point.
Where is probe?
Probably.
There is still
structure. We can get rid of it.
Yeah, I left it there hanging. Cool. Let's run all the tests again, and I think we are done a lot for today.
Cool.
Yeah.
Hey, it's working.
Lovely.
Cool. So star makes a copy, but Tomas, are you suggesting that for an integer we should be a little bit more picky, or it doesn't really matter? Because I think in this case it's okay to make a copy, right?
Yeah.
Okay.
Yeah, it's a pointer integers. Well, yeah, not a big difference. The pointer is even bigger, to be honest, than an I32. So
fair enough.
At least on your laptop.
Cool. So I'm gonna switch to the finishing screen.
Ooh,
and I'm going to do a commit after all of that.
Cool. Okay. So, well, as you know, you can find, or hopefully, you can find the recordings on YouTube. The links on Twitch in the About section. If you're watching this on YouTube, we live stream every Monday at 6 p.m. Irish time. So check us out if you fancy that. Feel free to leave us comments or open PRs. All of this code is on GitHub. There will be either a banner or a comment with the repo, which should point you towards it. Any sort of feedback and contributions are very well accepted. We're only learning, so our solutions aren't necessarily the cleanest or the most idiomatic, as you've seen earlier. So if you know better ways of doing things, do let us know, and we can all learn from it. Thanks for all the suggestions, questions, and collaboration from the chat. And I think we're going to raid someone, right, Luciano?
Maybe.
We're going to maybe raid someone.
Yeah, you're looking on your third laptop to see.
Nobody's live.
Nobody's live. Then
on the channels I follow.
It's the zombie apocalypse. Nobody's live.
Is Twitch even working?
Maybe. Yeah. Are we just talking among ourselves now, or are people actually?
No, well, at least Tommaso is there.
That's it.
Okay.
Cool.
We are ready to raid somebody. So see you very soon.
Thank you. See you later.
Bye.